In the segment on reasoning with resolution, we saw how to use resolution to answer true or false questions. For example, is Art the grandparent of Co? In this segment, we're going to look at how to use resolution to answer fill-in-the-blanks questions, such as, who is the grandparent of Co? Or who are the grandchildren of Art? Recall that our method for determining logical entailment is to negate the conclusion, convert to causal form, and try to derive the empty clause. Here's an example. Given P of x implies Q of x, given P of A, we can prove there exists a z such that Q of z. The clauses corresponding to our premises are shown here on lines 1 and 2, and the clause for a negated goal is shown here on line 3. Starting from these clauses, we can quickly derive the empty clause as shown on lines 4 and 5. Okay, now let's take this basic method and modify it just slightly. Instead of adding the negated goal phi to our premise set, we add a sentence of the form phi implies goal. To do, we're saying that if phi is true, then the conclusion goal is true. Having done that, we convert to causal form and we apply resolution. However, instead of trying to derive the empty clause, we try to derive a clause that contains just the literal goal. Now this is equivalent to what we were doing before, because phi implies goal is logically the same as not phi or goal. And so we just have a goal literal tacked onto each one of our clauses. Here's an example. We have the same premises as before, but instead of the negated goal, we have a clause for the negated goal with the goal condition appended. Same resolutions steps apply, and we end up with a clause containing goal. It's easy to see that for any derivation of the empty clause from a set of consistent premises and a negated goal, there's a derivation of a goal clause from the premises and our goal implication. In fact, the proof steps are one-to-one equivalent. So why are we doing this? Okay, the reason is that a simple extension of this method allows us to extract answers from our proofs. Suppose we have a sentence with some free variables, nu1 through nu-n, and we want terms such that when we substitute those terms for the variables, the goal sentence is true. If we modify our method just a little bit more, we can get resolution to give us these answers. Given a goal phi with free variables nu1 through nu-n, we add the goal sentence phi implies goal of nu1 through nu-n to our premise set and try to derive a clause containing just goal literals. If we manage to do this, then the arguments to the goal literal are the answers to our original question. By adding this new type of goal sentence to our premises, we're in effect saying that if anything satisfies our goal sentence, then it satisfies our goal. Okay, let's look at our example one more time. Except at this time, let's suppose that our goal is not just to prove that there exists a z such that Q of z is true. Let's suppose that we want to find a z such that Q of z is true. So our goal in this case is the open sentence Q of z. So as we see here on line 3, we write this as Q of z implies goal of z. Okay, we then execute the same steps as before. This time, because we include the variable z in the goal literal, it gets replaced by a on line 5, effectively giving us our answer. Nifty. All right, let's look at a slightly more interesting example. In this case, everything's the same except that we have two p-facts in our premise set. Our goal is the same as before. This time we do the resolution and keep on going. We see that we produce our answer from the last time, but we also get an additional answer, namely b. In other words, we can use resolution as a generator for answers to our query. Okay, one more example. Suppose that instead of knowing P of A and P of B, all we knew was that at least one of those facts were true. What would happen? Our disjunctive premise is shown here on line 2. The goal is the same. We start out as before by resolving our goal clause with a clause on line 1. Producing the result on line 4. Next, we resolve this result with a clause on line 2, resulting in the clause on line 5. Okay, now there's a non-goal literal in this result, so we can't just stop just yet. We want to stop only when we have clauses containing only goal literals. Fortunately, we can resolve, there are more resolutions we can do. In particular, we can resolve this result with a clause on line 2 once again. Sorry, do that with a clause on line 4, leading to the result on line 6. Now we have a clause containing just goal literals, and so we can stop. Okay, now let's take a look at this result. What exactly does it mean? Recall that a clause is an implicit disjunction. So from this result, we know that goal of A or goal of B. In other words, we know that one of the two answers is true, but we don't know which. It's not as good as knowing which one works. We know that at least one of them works. This method can be extended to produce other interesting results, such as conditional answers. For example, if the goal is true of all purple mushrooms and so forth.